Okay, so let's button up the user interface here. I'm just gonna go back to my start state, and again, not a bad idea to probably consider changing the state name. It's always good practice to keep state machines and states named appropriately. Now, because this is just a one-state machine, the player controller, we got a lot going on in one state. And just a real quick review, we're getting the forward direction of the main camera. I've hard coded a value along the z-axis here, just to get some force to be able to drive our just to confirm or debug or make sure that our force is working. So we're getting the camera direction. We're specifying the game object of the camera, and we're storing that in a camera vector 3. We're doing the get vector 3 xyz. That's a quick action to pull apart the vector 3 of the camera direction, and we're storing the x and the z. The reason we're doing that is because then we can add force, not based on the vector 3 like we usually do, not based on all three axes, but based on the x direction and the z direction. Now, if the only other thing that I want to do is, I have my original get access vector, and the get access vector is actually listening to the user input for the horizontal and vertical axes, and we're storing that in the player movement vector 3. Now, a real quick trick here is that rather than using this local direction, I'm going to turn on my get access vector. Rather than using this local direction and ramping up some value all the way up to 80 and seeing how that influences things, what we can do is, rather than using the local direction of 0, 0, 0, I'm just going to toggle that. The local direction, I'm going to use the player movement. In other words, I'm going to use the input for the get access vector. Okay, and the get access vector, if you recall, takes the horizontal and vertical and translates that to an xz, okay, the x and the z based on this multiplier here. And so as soon as I switch the local direction to the player movement, and I make sure that my get access vector is on, I should be able to control this now. I have my mouse look, and I'm doing the D key and the A key, and that's relative to the camera. I'm doing the W and the S. Now my multiplier, or my speed value, obviously is way too low. But that's something that I can correct for pretty easily. So now I have control based on the actual input of the direction of the camera. Now, technically, I could probably get rid of this get vector xyz. I may be able to get rid of that. Let me just temporarily turn that off. And that's usually how I like to troubleshoot these things. I should be able to turn that off and go back to adding force rather than peeling apart the xz direction. I'm just going to experiment with this. I'm going to set this back to none and this back to none. And I'm going to do our original vector 3, not player movement. Let's try camera direction. Let's see if that gives us what we want. That's actually not going to give us what we want. Maybe it is. Let me see. Camera direction. Okay, we're getting the power. Let me see if we can set this back to player movement. Yep. So the player movement is very slow. Okay. But again, that's because of the speed is very low. Now there are some advantages of peeling out the X and the Z. As I mentioned, the reason I was able to get away with doing this is because if you remember, when we do a get access vector, we're listening for an X. Well, in this case, we're listening for X and Z based on horizontal and vertical. So this is actually inherently ignoring the Y axis anyway. So when we generate user input, we're generating the X over here and the Z over here, and that Y always stays at 0. So we can actually work around that, peeling that vector apart. But whichever way you want to do this, either way is going to give you those results. And so I can steer this around, and again, I should be able to go into variables and global variables and take that speed value. Let me crank this way up to like 40. And now if I have things built properly, I should be able to drive this sphere around much faster. There we go. And I just flew off the edge. So there we have it. That's a user input. That's about as complicated as it gets in terms of, I might be having a little bit of glitch in my direction here. Yeah, it looks like I'm mapped back to, it doesn't look like I'm using the camera coordinate system here. So I got a little bit of a glitch here. I'll probably set this back to the camera direction and see if that gives me the results that I need. Yeah, okay, so, well, but you know what, I'm running into that same issue where I can actually fly here. So it does look like pulling apart the X values over here, the X and Z value, because I can't seem to avoid that Y. So everything's set up properly. The only thing is in the add force, I thought I was able to work around by still using just a vector. That's not the case, so I got to set that back to 0 and go back to my X direction solution and my Z direction solution. So let's see if that force is still picking up the speed. It should. Nope, it's not working, and the reason it's not working is because I forgot to turn on my get vector 3. There we go. Turn that back on, and I can see all the debug options happening here. There we go. So I'm getting the results, the exact results that I wanted. Everything looks good. Now I do have one more glitch that I might as well squash while I'm here, and that is that I can actually orbit underneath the player object, and I really don't want to do that. You can see that it kind of locks. It looks like it locks at a negative, some kind of rotation value here. And I can correct for that under the camera where we're doing the mouse orbit script. I could limit the Y instead of a -20. Let me just try to zero out that value, the Y minimum. And let's see if that allows me. Yeah, there we go. So now I can't orbit under the floor. So that'll be helpful. So there we have it. That's about as complex as our player control setup, excuse me, is going to get. We'll push forward in the next presentation, and I'll show you a real quick alternative that goes back to a simple follow camera that gets the position of the player character. But we'll do that in the next presentation.